This video is about using Newton's second law of motion to solve problems involving moving lifts. So let's go straight into examples. So let's call this A. Let's call this A and B. There's two parts to this question. A person of mass 70 kg stands on the floor of a lift which is accelerating downwards at 2 meters per second squared. What is the force exerted by the lift on the person? So for A, we've got a person. The person weighs 70 kg, so the weight is 70 times g, so 70g. It's a reaction force from the lift, obviously. So the lift is exerting a force on the person. So this is what we're trying to find, which is R. And they're accelerating downwards at 2 meters per second. So accelerating downwards by 2. Okay, so we're going to apply Newton's second law to the man. So Newton's second law. So vertically on man, which means resultant force is equal to mass times acceleration. We're moving downwards, so resultant force is 70g take away r, which is equal to mass, which is 70, times acceleration, which is 2. Which means r, when we rearrange it, will be 70g take away 70 times 2, which is 140. If you put that into your calculator, you get r is equal to 546 newtons. Okay, for part B, a person of mass 70 kg stands on the floor of a lift which is accelerating upwards by 2 meters per second squared. So now we have the man, it still weighs 70 kg, a person, sorry, 70g, reaction force still, but now accelerating upwards by 2. So now again we have to set up Newton's second law for the man. So Newton's second law vertically for man. Resultant force is equal to mass times acceleration. This time the lift is moving up. So we're trying to find what is the force exerted by the lift on the person. So again, we're trying to find R. So if it's moving up, then the resultant force is R take away 70g, which is equal to 70 times acceleration, which is 70 times 2. So R must be equal to, if we rearrange it, 70g plus 140. So R must be equal to 826 newtons. Okay, NB, the reaction force does not equal weight in this case. Just so you know, you can see from this example that it does not equal to weight because obviously it's accelerating. The lift is accelerating or the man is accelerating. Okay, next question. A box of mass 8 kg sits on the floor of a lift. On top of it sits another box of mass 5 kg. Calculate the reaction force between the bottom box and the lift if the lift accelerates upwards by 5 meters per second squared. So in this case, we've got a lift. So we've got a lift. We've got the bottom box. And then we've got the top box. So if we draw it out separately, the top box, what does that mean? So top box is sitting on top of the obviously box, which has mass 5 kg. So weight will be 5g. And obviously you'll feel a reaction force. Let's call this R1 from the bottom box. The bottom box will feel its own weight, which is equal to 8 kg times g, 8 times g, which is 8g. Plus, it will feel, obviously, the top box pushing down on it. So, plus R1, which is the same as, obviously, what the top box feels. And then the bottom box will also feel R2, reaction force, which is obviously the lift pushing up. So, that would be it. We know both of them are accelerating upwards by 5. So, 5 for accelerating upwards. And if we look at the lift will obviously feel its own weight. We don't know what that is. So weight of lift plus the reaction force and over tension of moving up. So calculate the reaction force between the bottom box and the lift. So what we're trying to find is R2. order to find R2, first we have to find R1. So Newton's second law vertically on top box, then we get resultant force is equal to mass times acceleration. Because it's moving upwards, it's R1 minus 5g is equal to 5 times 5, which means R1 will be equal to 25 plus 5g, which is equal to 74 newtons. That wasn't what we're trying to find. We're trying to find the reaction force between the bottom box and the lift. So what we're trying to find is R2. So now we need to do Newton's second law, obviously, for the bottom box. Then resultant force is still equal to mass times acceleration. Resultant force will be R2, take away 8g, take away R1. Now we just worked out R1 is 74, so I can just write 74 is equal to mass, which is equal to 8, times acceleration, which is 5. So if I rearrange it, R2 will be equal to 40 plus 8g plus 74. So R2 will be equal to 192.4 newtons. Okay, next question. A box of mass 6 kg sits on the floor for lift. So we calculate the reaction force between the box and the lift. So we don't have to draw the lift in this case. All we know is box has weight 6g because the mass is 6 kg. And it obviously feels the reaction force from the lift pushing it up. Okay, so A, calculate the reaction force between the box and the lift if the lift accelerates upwards by 3 meters per second. So that means it's going up by 3. The Newton's second law vertically, there's only one item, so I'm not going to write down what that is, will be F is equal to mass times acceleration. The resultant force is equal to R take away 6g must be equal to 6 times 3. So R is equal to 18 plus 6g. So R is equal to 76.8 newtons for A. For B, the lift accelerates downwards at 2 meters per second. So now it's traveling down by 2. So Newton's second law vertically, then F is equal to mass times acceleration. So if it's going down, then the resultant force is 6g take away R is equal to 6 times 2. So R will be equal to 6g take away 12. So R must be equal to 46.8 newtons. So that would be B. For C, the lift ascends at a constant velocity, which means acceleration up is just 0, so it's not moving, which means Newton's second law applied vertically again. That means the resultant force must be equal to 0 as well, because acceleration is equal to 0, which means R minus 6g must be equal to 0, which means R is equal to 6g, which means R is equal to 58.8 newtons. For D, the lift decelerates downwards at 4.2. So it's going downwards, but it's decelerating at 4.2. So if it's decelerating, we say it's negative 4.2. So it's going down by negative 4.2. So Newton's second law again, applied vertically, then F is equal to mass times acceleration. Because it's going down, it's going to be 6g minus R is equal to mass, which is 6 times acceleration, which is negative 4.2. So the reaction will be, force will be 6g minus 6 times negative 4.2, which gives us R is equal to 84 newtons. Okay, next question. A box of mass 8 kg stands on the floor for lift. On top of it sits another box of mass 5 kg. Calculate the reaction force between the bottom box and the lift if each of these scenarios is happening. So we've got the top box. Let's just call it top box. It has weight 5 kg, so it's 5g acting downwards, and it's got a reaction force obviously from the bottom box pushing it out. Then for the bottom box, because it weighs 8 kg, it feels its own weight, 8g, plus it feels a reaction force, obviously, from the top box, pushing it down. And because it's sitting on the lift, it feels the reaction force from the lift pushing it up, sorry. Now the lift feels its own weight. We don't know what the weight is. So weight of lift, plus feels the reaction force from the bottom box pushing down, and then there's tension on the lift. Calculate the reaction force between the bottom box and the lift. So which means we're trying to find, in these cases, we're trying to find R2. Okay, so it means for each situation we'll have to do two things. Okay, so first thing is A is accelerating upwards by 5 meters per second squared. So 5. So Newton's second law vertically on top box first in order to find R1. So that means we get, because it's moving upwards, we know R1 minus 5g must be equal to 5 times 5, which means R1 must be equal to 5 times 5 plus 5g, which works out to be 74 newtons. So now we apply Newton's second law vertically on bottom box, which means R2 minus 8g minus R1, which is 74, must be equal to 8 times the acceleration, which is 8 times 5, which means R2 must be equal to 40 plus 8g plus 74, which implies R2 is equal to 192.4 newtons. Okay, so part B says the lift accelerates downwards at 3 meters per second squared, so it's now going down by 3. So Newton's second law applied vertically on top box, because it's traveling down now, then the resultant force is 5g minus R1 must be equal to 5 times 3, which means R1 is equal to 5g take away 15, which is equal to 34 Newton. Newton's second law applied vertically on the bottom box means, because it's traveling down, 8g plus R1, which is 34, minus R2 must be equal to 8 times acceleration, which is 8 times 3. So R2 will be equal to hg plus 34 minus 24, which works out to be R2 is equal to 88.4 newtons. Okay, for part C, the lift accelerates upwards at negative 0.8 meters per second. So going up at negative 0.8. So Newton's second law applied vertically on top box, because it's traveling up again, R1 minus 5g would be equal to mass, which is 5 times negative 0.8, which means R1 would be equal to 5 times negative 0.8 plus 5g, which is equal to 45 newtons. So Newton's second law applied vertically on bottom box, because it's traveling up again. That means R2 minus 8g minus R1, which is 45, must be equal to 8 times acceleration, which is 8 times negative 0.8. So R2 will be equal to 8 times negative 0.8 plus 8g plus 45, which implies R2 is equal to 117 newtons. Okay, the last case, which is D. The lift decelerates downwards, it's going down at 2.7. Because it's decelerating at 2.7, it means that it's accelerating as negative 2.7. So going downwards, but with acceleration negative 2.7. So Newton's second law vertically on top box means we get 5g minus R1 is equal to mass, which is 5 times acceleration, which is minus 2.7, which means R1 will be equal to 5g take away 5 times negative 2.7, which works out to be which works out to be 62.5 newtons. Okay, so now we do Newton's second law vertically on bottom box. Because it's traveling down, we know 8g plus R1, which is 62.5, minus 62.5 minus R2 is equal to 8 times negative 2.7. So if we rearrange it, R2 will be equal to 8g plus 62.5 minus 8 times minus 2.7, which implies R2 is equal to 162.5 newtons. Okay, next question. A man of mass 70 kg stands in a lift of mass 300 kg. Calculate the tension in the lift of the lift cable and the reaction force between the man and the lift if these two scenarios are happening. So we've got a man who weighs 70 kg, so weight will be pulling him down with magnitude of 70g, and there's a reaction force from the lift. The lift feels its own weight, which is 300g, plus the reaction force from the man, and then there's a tension in the cable. So in these cases, we're trying to find the tension and the reaction force, so we have to find both T and R. Okay, so in A, the lift accelerates upwards by 3 meters per second, so going up by 3 meters per second. So Newton's second law applied vertically to man is resulted. So because it's accelerating upwards by 3, R minus 70g must be equal to 70 times 3, which means R is equal to 210 plus 70g, which is equal to 896 newtons. So that's the reaction force between the man and the lift. So now we need to work out Newton's second law applied vertically on lift. Then tension minus 300g minus R, which is 896, must be equal to mass, which is 300, times the acceleration, which is 3. So T will be equal to 900 plus 300 G plus 896, which implies T is equal to 4,736 newtons. Okay, part B now. The lift accelerates downwards by 2.5 meters per second. The Newton's second law applied vertically on man. Because it's traveling down now, 70g minus R must be equal to 70 times 2.5, which means R will be equal to 70g minus 70 times 2.5, which implies R is equal to 511 newtons. Newton's second law applied vertically on lift. Then what we end up getting is, because it's traveling down, 300g plus R, which is 511, minus tension is equal to 300 times the acceleration, which is 2.5, which means if we rearrange it, T will be equal to 300g plus 511, take away 300 times 2.5, which implies T is equal to 2,701 newtons. Okay, C, its lift accelerates upwards by negative 1.7, so negative 1.7. Then Newton's second law applied vertically on man. Then because it's going upwards, it's going to be R minus 70g must be equal to 70 times negative 1.7, which means R must be equal to 70 times negative 1.7 plus 70g, which implies R is equal to 567 newtons. Now if we apply Newton's second law vertically on lift, that is traveling up, which means T take away 300 G take away R, which is 567, must be equal to 300 times negative 1.7, which means T must be equal to, when you rearrange it, is 300 times negative 1.7 plus 300 G plus 567, which implies T is equal to 2997 newtons. The last case is the lift descends at constant velocity, which means acceleration is equal to 0. So it's neither moving up or down, so it doesn't matter which way you draw the arrow, as long as you label it 0. That means resultant force is equal to 0. Which implies R must be equal to 70 G, which is equal to 686 Newton. And tension must be equal to 300 G plus R, which is 300 G plus 686 newtons, which means T must be equal to 3,626 newtons. Okay, a woman of mass 60 kg stands on a lift of mass 200 kg. She's holding a parcel of mass 10 kg, which is suspended from a light string but does not touch the floor of the lift. Calculate the tension in the lift cable, the reaction force between the woman and the lift, the tension in the string suspending the parcel if these scenarios are happening. So there's a parcel first. So the parcel feels its own weight, so it's 10 G. There's a tension, which is, there's two types of tension happening, so let's call it T1, tension on this parcel string. There's a woman. She feels her own weight, which is 60 G, plus the tension pulling her down from the parcel string. And then there's a reaction force with the lift. The lift feels tension pulling up, which is tension 2, different to tension 1. It feels its own weight, which is 200 G, plus the reaction from the woman, obviously the force from the woman pushing down. It's a reaction force. Okay, so now we need to obviously work out tension in the lift cable. This is T2. The reaction force between the woman and the lift is R. Tension in the string suspending the parcel is T1. So for each of these cases, we need to work it out. So that means there's 3 things we need to work out. So now accelerating downwards at 1.2, which means Newton's second law applied vertically to parcel first. That means because it's going down, 10G minus T1 must be equal to 10 times acceleration, which is 1.2. So T1 must be equal to 10G minus 12, which is equal to 86 newtons. Okay, Newton's second law applied vertically to woman. Then we know because it's moving down, 60G plus T1, which is 86, minus R must be equal to 60 times 1.2, which means R will be equal to 60G plus 86 minus 60 times 1.2, which works out to be 602 newtons. And then Newton's second law applied vertically to lift. Then as it's going down, we know 200G plus R, which is 602, minus T2 must be equal to 200 times 1.2. So T2 will be equal to 200G plus 602 minus 200 times 1.2, which works out to be 2322 newtons. Okay, part B, the lift decelerates downwards. So going down, deceleration of 0.9 meters per second. means acceleration is negative 0.9. So that means Newton's second law vertically on parcel gives us 10g minus t1 is equal to 10 times negative 0.9. So t1 will be equal to 10g minus 10 times negative 0.9, which is equal to 107 newtons. Okay, Newton's second law applied vertically to a woman. We end up getting 60g plus t1, which is 107, plus 107 minus r must be equal to 60 times negative 0.9, which means r must be equal to 60g plus 107 minus 60 times negative 0.9, which works out to be 749 newtons. Newton's second law applied vertically to lift means we get 200g plus the reaction, which is 749, minus T2 must be equal to 200 times negative 0.9, which means T2 must be equal to 200g plus 749 minus 200 times negative 0.9, which works out to be 2,889 newtons. Okay, part C. The lift accelerates upwards at 2 meters per second. So again, Newton's second law applied vertically to parcel. Then we get T1 minus 10g is equal to 10 times 2. So T1 will be equal to 20 plus 10g, which is equal to 118 newtons. Okay, Newton's second law applied vertically to woman. Then r minus 60g minus t1, which is 118, must be equal to 60 times acceleration, which is 2. So r will be equal to 120 plus 118 plus 60g, which works out to be 826 newtons. Newton's second law applied vertically to lift. That means T2 minus 200g minus r, which is 826. 826 must be equal to 200 times the acceleration, which is 2. So T2 must be equal to 400 plus 200g plus 826, which works out to be 3186 newtons. Okay, part D. The lift decelerates upwards at negative 3.5. So it's decelerating by negative 3.5. That means it's accelerating by 3.5. So that'll be 3.5 there. So Newton's second law applied vertically to parcel. Then we get T1 minus 10g must be equal to 10 times 3.5, which means T1 is equal to 10 times 3.5 plus 10g, which works out to be 133 newtons. Newton's second law vertically to woman. Then that means we get r minus 60g minus the tension 1, which is 133, must be equal to 60 times the acceleration, which is 3.5. So r will be equal to 60 times 3.5 plus 60g plus 133, which works out to be 931 newtons. And the last part, which is Newton's second law applied vertically on lift. Then we get T2 minus 200g minus r, which is 931, must be equal to 200 times 3.5, which means T2 is equal to 200 times 3.5 plus 200g plus 931, which works out to be 3591 newtons. Okay, next question. A man of mass 75 kg is standing in a lift. He is holding a parcel of mass 5 kg by means of a light inextensible string as shown in figure 5. The tension in the string is 55 newtons. So we know, find the upward acceleration. So first thing we do know is we've got a parcel which is being held by a string. We know the weight of the parcel is 5 kg, so the mass is 5 kg, so the weight will be 5g. It's being held, the tension on the string is 55 newtons, so you know 55 newtons pulling up. Now the man feels his own weight, which is 75g, plus the tension from the string, which is 55. There's a reaction force from the lift, and the lift feels its own weight, plus reaction, tension pulling it up. Find the upward acceleration. So what we need to do is for the parcel, because we know the resultant force of the parcel, it will help us find the acceleration. So part 1, Newton's second law applied vertically on parcel. Then resultant force is equal to mass times acceleration. So we know this acceleration is moving up here. So that means resultant force will be 55 minus 5g must be equal to 5 times acceleration, which means acceleration will be 55 minus 5g divided by 5, which means acceleration is 1.2 meters per second squared. Find the reaction on the man of the lift floor. Okay, so if we apply Newton's second law to Newton's second law vertically on man, then we have resultant force is equal to mass times acceleration. It's moving up, which means R minus 75g minus 55 will be equal to 75 times 1.2, which means R will be equal to 75 times 1.2 plus 75g plus 55. R works out to be 880 newtons. As shown in figure 4, boxes P and Q are descending vertically supported by a parachute. Box P has mass 75 kg, box Q has mass 25 kg and hangs from box P by means of a light vertical wire. Air resistance on the boxes should be neglected. At one stage, the boxes are slowing in the descent with the parachute exerting an upward vertical force of 1030 Newton on box P. The acceleration of the box is A meters per second squared upwards and the tension in the wire is T newtons. Part 1. Draw a labelled diagram showing all the forces acting on box P and box P, and another diagram showing all the forces acting on box Q. So if this is P and this is Q, Q feels its own weight, so its own weight is 25g. It will feel the tension from the wire. Box P feels its own weight, which is 75g. 75g plus the tension from the wire. And we know that there's a vertical upwards force of 1030 newtons on box P. So 1030. And we also know both of them are accelerating upwards. So A. Okay, part 2. Write down separate equations of motions for box P and for box Q. So for box P, we know that 1030 minus 75g minus t is equal to 75 times acceleration. Box Q is, we know t minus 25g must be equal to 25 times acceleration. This is using Newton's second law. Newton's second law. Okay, and then calculate the tension in the wire. So if I want to calculate the tension in the wire, the first thing I need to do is simplify the first equation. So when I simplify that, 1030 take away 75g is 295. Take away t is equal to 75 times the acceleration. 245g is just 245, and so it becomes t take away 245 is equal to 25 times a. So all I've done is I've simplified this bit and I've simplified that bit to get those two equations. So if this is equation 1 and 2, I know one has negative t, one has t. It's the second one has t, which means if I do 1 add 2, I'm going to get rid of t. So when I do 1 add 2, all I'm left with is 50. So 50 is equal to 100a, which means a will be equal to 50 divided by 100, which is equal to 0.5 meters per second squared. But that's what we're trying to find out. We're trying to find out t, so we can use either of these equations. So substitute a is equal to 0.5 into equation 2. Then we get t minus 245 is equal to 25 times 0.5, which means t will be equal to 12.5 plus 245, which means t is equal to 257.5 newtons.